Hello, my name is Marcin Stożek. I work at Collective Sense. It's a small startup based in Krakow. Sorry, I will have some. I need to have something for my sore throat. So at the beginning, I will just do the clicking all the time. But that was, for first 5 minutes or so. So first the story. Imagine the story like that. You need to you have an application and you need to do a call to this application, but the call is going to be based on some other things like header or I don't know, the client ID or API key or something like that, and your application does not support that. Your application is just like that. You just you were given this from the from some outside party, and you need to incorporate some new behavior into that. And I had this situation. I needed to add some things, and I've spent some time researching how to do it in the proper way. I didn't know anything about the IP gateway and so on. So my first thought was to do, okay, I can do it in Java, but that seems a little bit too much for just passing the request if the request is something. I could do this in CGI. Oh, that is a bright idea. But I don't know if you've used CGI recently and you remember how to use CGI. You have to have the CGI server and you have to proxy the request to the CGI server, and then do everything that is needed to be done with this request. And that's a lot of things to do with such small thing. This is not easy. I've spent like, I don't know, 1 day or 1.5. I was really crying after that time. I had no idea what to do with that. I was not happy with the solution that I've came up. And what I did, I went to the kitchen, because in the companies you talk to people in the kitchen, not when you sit in front of a computer. And I met my friend, which is quite a good computer scientist, a security guy, and he told me, why haven't you used the OpenResty? And I asked him, what is OpenResty? I haven't heard about such things, in my life. And he told me, oh, OpenResty is just Lua incorporated in the nginx. This is a really nice thing. You just go and see. So I did it. I went to my computer. I sat. And after 3 hours, I had a solution that I was really happy with it, that changed my mind about things you could do with the request on the fly, I thought that it's a really good idea to start talking about this, because it appears that people don't know about API gateways. So glossary. nginx, I hope everyone knows what is nginx, so I won't be saying about that much. We have Lua. This is programming language, 1993, from Brazil. Lua in Portuguese means just moon. That's why the touch of a moonlight. We have it here. Guys that did the Lua could not use any other language, and there was not many languages at the time. They could not import because of the Brazil import policies, so they needed to incorporate some language into other system, so they came up with Lua. Lua is really consistent, small, and nice for small things. We have OpenResty. This is just nginx with Lua module configured. You can add many modules into nginx, and one of them is the Lua module that you can write Lua scripts. And I will be talking about Konk, which is just this OpenResty from here, but with some plugins that you can just use. So you do not need to write your own custom scripts. Short intro to Lua. This is really short. The things that you need to know: arrays from one, strings we concatenated with double dot, nil, non-equal, comment, and or not, and every variable and function is global. This is important. So you need to use local keyword a lot if you don't want to mess up your scripts. Lua is really nice because of a couple of things. First of all, it's really small. You can run it on the embedded hardware. The compiled Lua is like 180 kilobytes, so it's not that much. And Lua has something called Lua JIT, and Lua JIT means you have your Lua code, you compile it into the Lua bytecode. Lua bytecode, if you want to see this, it's just a couple of strings. It moves some registers and this kind of things, and this is really fast. It's the fastest JIT I think up to this point. And the idea about Lua JIT, how it is made, is the same like we have in Dalvik, for example, in Android. And the Lua the Lua language is small and concise. You don't have many things, many keywords in Lua and so on. So you can learn how to write it in very short amount of time, and you don't have problems. And I say, if you can read and write, you can read and write Lua because it's that easy. And it's not like with some other languages, or I don't know, regex. When you write regex, it's okay, it works, but then try to read it. It's a little bit problematic from time to time. And it's not like the other language, which there's this saying, someone had problems. Someone was struggling to write it, so someone else need to struggle to read it. And this is obviously about Perl, and Lua is not like Perl. It's not at all. So, hello world. I will just show you the hello world, how to incorporate this Lua into the nginx. On the left we have the just simple nginx. We just serve the data from the root data, and here on the right we have OpenResty. This is content by Lua block, and this is added by this Lua module, and we have just this real simple thing like, please, dear nginx, say hello world. Let's just see if that works. Demo. This is space-driven demo, so I will just enter and space. Oh, and we see this. This is hello world. And how I did this? Let me show you. Demo is just a Docker compose that created some application, and then we have on the port 80 some application running, and Docker compose is like that. We have OpenResty image that uses port 80. It's called app, and we have this configuration file, which is the file I showed you before. Yeah, so it's just hello world. Great, isn't it? You can do things like hello world. It's really nice. How to do this? You have a couple of sections in the nginx configuration file, right? So you have the initialization section. You have request section, response section, and log, and you just concatenate those two things. So you take, for example, rewrite, and you say rewrite by Lua file. And you can use file, or you can just inline Lua block. That just depends on what you want to achieve. And Lua is this Lua module is really nice because you can incorporate this into nginx in many places. You can actually I didn't have any problems, so I could incorporate it in every place that I wanted to. Okay, so see some examples. We have the correlation ID. This is a true story. We need to add correlation ID on every request that comes to our applications. So we do this at the gateway, and then just add this header or something to every request that goes to our application. And the other thing is that we don't want this correlation ID leak to outside, so that no one knows we mess with those requests at all. So how to do this? First, this is not complete file, and by the way, if you want to see those files complete, it's available on my GitHub account, and there will be a link at the end of this presentation. So no worries, you can check me. You can run this on your own hardware and see if that's working. This is Lua code. I just have my correlation ID variable, which is some math random, and I log that I created the correlation ID. Then I return this correlation ID, and this is put into this variable, and this variable is used here. So I add the header correlation ID with this variable, and then I do just proxy pass to my application, and I do this on the request side, and on the response side I do some other things. If I get the header, I change something. Okay, let me show you this. And what I will be doing, I will just set up my application with the Docker Compose and do some simple curls. Correlation ID. Okay, maybe show you the Docker Compose. So this is easy. As before, we have some OpenREST image here that serves on port 80, and we have 8080. This is for our app, so that we can go, directly to our app, to our app, or we can go through the proxy. And let me show you this. Okay, we have our containers running. This is nice. So first, I'm calling the app, and as you can see, I did this, and I have it here. I've sent correlation ID like this, and my app is done in such way when it when it is given the correlation ID header, it adds the app correlation ID. Just bounce it back to us so that we can see this. And if we call the proxy, then we have the correlation ID in here, but we don't have it in here. So it works. It means that our correlation ID was cut off, and we don't have it anymore in the response that goes to the client that was the original caller. And now I will show you the original and proxied body of those applications. So this is the response from the app on the 8080. So it's directly from this from the application, and another one will be from the proxy. And if you can see this, the body has changed, and the body has changed because I can do everything with my request, and I can change the body as well. There is no problem with that. So this is really cool, because if I have some legacy application and I know that this legacy application does not work properly or works in the way that I don't want it to, I can just change it on the fly, and there's no problem with that. This is a really cool feature. And that's this is the second one. Okay, bye-bye. We don't need you. Okay, that's all for the correlation ID. We can do a lot of other things, like we can set the HTTP session on our proxy on the proxy server, and we can do it with Lua as well. We can see the Lua Rocks install. This is just Lua package manager for Lua scripts, and it's really nice because this is just library, Lua REST session. And if I want to have a session on my proxy, I just install the library, and I have just added some endpoints like create session, check session, destroy session, and the code is really concise. It's small. I don't need to do many things with that. I can here the session is stored in the cookie. I can store the session in some database as well, and I don't need to have any other, outside service to manage my session if I don't need to, right? This is really simple. Maybe skip the session demo because we don't have time, and show some other things like dynamic routing. So I will just show you that we can route to other applications based on user agent, and this will be done here with the OpenRest as well in the with the Lua. How to do this? I have my access by Lua block, and proxy pass is done to the target, which is set here. So I first read the HTTP user agent. I have connection to my Redis, and if my Redis have the key associated with the user agent that I give it to, then it gives me target, and I just proxy pass to this target. It works on the fly. I don't need to change my nginx configuration, and is as fast as the Redis connection. Redis dynamic routing. Okay, so what is it doing? First, it created Redis and some application like foo, bus, bar, cooks, and proxy. Now I've added some keys into the Redis database, so that if I use the user agent foo, I will go to foo. If bar, then bar, bus, and so on. And now let's see if that works. I'm just doing this calls, and I'm foo, I'm bar, I'm bus, and cooks. So it's working. And if I use foo bar, there was no foo bar key. I just I'm just being given the bad request. Okay, global variables. This is important because every variable is global in Lua, so you need to take that into consideration, and you can use it if you want to share the DB connection, because connections to the Redis are pricey. You cannot connect every time to Redis because it will be really slow, so you want to share the connection. But if you share this, you need to know a couple of things. First is that the connection, the global variables is global but only per worker. So if you have like 20 workers, you will have 20 connections. And other thing is that you need to make sure your database library is thread safe, which means this is important because of how the nginx works. We have a worker, and the worker gets the connection and spawns some other process that is going to do things with our request. So and this is really fast. It do not wait for the response. It just creates all of those processes, and this is per worker. Those are all children of the same process, of the same parent, and they all share the same DB connection. But if we use this DB connection at the same time, we'll have problems with just threads, because all the threads will be going to the same database, and which is which. We need to make sure it's working fine. I will show you this because it's worth it. First, okay, this is diff between the configuration. So we have 1024 worker processes and one. So one worker, it's easy. We have just, is it working? Yep. We don't see this, but I can show you it. This Can I? Not really. Oh, okay. It's a bummer. But you need to, you can check it yourself. It just goes a counter from 1 to 30, and then we have 1024, and it just, starts all over again because of the every worker. It's different. We can do some other things, like we can have fun with images. We can dynamically resize those images. I know that we can do this using just nginx module, and this is not a problem, but this module does not do as many things as we can do in here, because here we add some security, which means we resize images and create thumbnails from those images, but only once, and if you give me the SHA function of the file, and it's done like this. We have this path which takes the signature, and we have the size, and then the name of the file. We just do MD5, the digest of this size and path, and then we try those files. First, we try the thumbnail that was created before, and then if not, we try to use the image server, which is here defined. This is just Lua file that do the resizing actually, and I use just two libraries, which is Magic, and this just calls the Magic library underneath from the system, and Lua file system, so that we can store files and do things with that. Here we have a little bit of code. This is easy as well. Not found, we just return not found. Calculate signature, we just calculate it. And that's it. I think it's not worth to show it for too long. And here I have the applications show links, so that I don't show you the links, because the signatures are different from all the sizes and the image names, and I don't know them. So I've just created another application which is really small and creates those signatures for me with the links, so that I can click on them with those resolutions. And we have this user story. The business comes to us and say that we have new users in New Zealand, and they are they are upside down because they are on the other part of the globe, so they don't need to rotate the phone because it's stupid. It is, right? But business is business. We don't think about that too much. Just do it and don't ask questions. And see if that works. Okay, so here we have a couple of links with some images, and to show you that it's okay, maybe show you this. Okay, it's working. This is 640, and here is twice as big, and this is done. This is done on the fly, and please notice the signature. In here it changes because the files are different, and we have the security incorporated, because if I change it, it won't work anymore, or I hope so. No? Why you do it to me? Okay, it shouldn't work. Something is wrong in here. Okay, let's skip it and pretend it didn't happen. Okay. Web Application Firewall. I don't know if you are familiar with the term. It's the short term is WAF. You use it for firewall your web application requests, and this is important feature for the applications that we are given from the outside and are not secure, because they are, I don't know, they are old, or they are they were just bought from, from some company that 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 we don't want to, how to say it nicely. We don't want to, do deals with them anymore. But we have the application that is running, and we used WAF, and we can use WAF in Lua as well. We can use some, other web application firewalls that are sold because they are commercial ones. But this is really cheap because it costs you 0, or it costs you maintaining your web application firewall, but you need to maintain other one as well. This is deployed as reverse proxy, and it gives you active defense on the request. It scans every request and say you have some malicious thing in the request, and it tells you, oh, this is malicious. No, I don't want you to respond to that. We can change the code of the application if we don't have the source code, and we can change it on the fly, which is really nice. We can use honeypots. So I don't know, we have application and we add to this application, like, to the every request we put into the body, like debug is false. And then we see, because debug is false, and we just add it to the application, it goes to client, and then we scan it backwards. So if we see debug is true, we know that someone has done some things with the code, was looking into the code and change it. So it wants to see what the code does when we debug, when we true debug. So what we do, we then take all of those requests that are debugged true, and we just proxy them to the other server, because it do not have to be really fast. And on the other server we can enable logging, and we can log all the things that the requester does, and we have a really nice information about what the other user or the attacker does with our application, in which ways he wants to deal with that, and our application is still secure because we don't use the real application, we just use the other one. And the other nice thing is that no changes are needed in our web application. So this is vanilla, and we don't need to do with this anything. If you're familiar with the Cloudflare, they use web application firewall, which is written in Lua, and on top of nginx, and that should whistle some run some bells, because it sounds familiar. This is the same guy that did the Lua module for the nginx. It's the same guy that worked for Cloudflare and did this web application firewall, as far as I know, and it works, and it must work really fast, because Cloudflare, the traffic on Cloudflare is amazing. It's like really huge, and they still do this. They still scan every request with their web application firewall, and for me that proves that the Lua is fast. Let me show you this. This will be really simple. What are you doing? Stop. Okay, we have our applications running. Now we are running the normal request, and we just got the normal response on the app, and this is vanilla. And now we are running the malicious request, and it is malicious because it contains JavaScript alert, and we do not allow such alert. So our web application firewall, which is OpenResty, just bounced back the and has given us forbidden, so we are not allowed to connect to the application anymore. And it's really easy. I urge you to use such things. And we have this Konk. Konk is just this OpenResty with plugins, so you don't need to know Lua that much, or for happy paths you don't need to learn the Lua. and it's easy. When you want to add some things, you just go to the Konk website. They have open source and commercial support, and you just use the plugin. You can write your own plugin, and you just enable it on the Konk server, and it works. And you do everything via the API. There is a commercial UI and there are some open source UIs, but I did not use them, so I don't know. I will be running 3 things. First, I will show you how to add our application service, which is just this will be accessible as app from the Konk. So I have this app service added to the Konk, and it knows that it has this mapping. Then I will add the authentication for this app service plugin, and the other plugin will be the correlation ID plugin. So the same thing that I showed you at the very beginning. Okay, thanks. First, we need to create application and the Konk database. It needs to have the Postgres or something else. I don't remember exactly. And it needs to be configured. So we are going to run the migrations for that. Okay, it's done. Now I'm going to run Konk. Let's wait a bit. Okay. Okay, so now it's working, and now we are just adding on the fly to the running service some things. Oh, something happened. Okay. This is this thing that I showed you before. So here we are adding the application service, and we see that it has been added. Then we need to add the proxy to this, and it's done like here when it will be given app local in the host header. It will route our request to the application, and here we can see that it's not proxying when the header is absent. We just were given the no route and no API, and if we do it, okay, because it done it twice. Yeah, it done it twice. So first it was run with the header host app local, so it responded with the application, and then without the header, and we were given nothing. Then I'm adding the correlation ID plugin as before, and now we'll check if the correlation ID is there, and we see it here. This is app correlation ID that was bounced from our application. We don't see the correlation ID which was sent to the application because it was done by the Konk underneath. And now let's just add some authentication. So here we are adding plugin. Now we need to add some consumer to the so that some people can access and some people cannot access the application. So we create a key for this user alias, and now check if we have the access. We don't have the access if we don't have the, where is it? Here. If we don't have the API key, and if I change it, let me just copy and paste this. Bach. Here, and use this API key. Where are you? Here. And we have the application. And if we change this, it's not working. Okay. Better this time. Okay, and is it fast? It depends, but there are some benchmarks that says it is fast. And this is mostly because of the Lua JIT and how it is incorporated into the nginx. And the important part about this talk as well is that it works on nginx, but it won't work on Apache or other application servers, because the module for the Lua is written especially for nginx. But as far as I know, there are modules for other servers as well that you can incorporate Lua in there. Let's see some speed demo, speed test. First, I want to show you because I am running everything inside the Docker container, and I want to show you the difference between running the speed test when I run the benchmark through the Docker proxy. I don't know if you're familiar with the term. If you run Docker container and it is not bound to your host network, everything goes through the Docker 0 network, and there is the Docker proxy binary running as well to move our packets, and that is slow. So I want to show you how slow it is. This is some benchmark. How much is it? Like 4,000 here, 4,000 requests, 4,300 requests. And now let's do this, but through the host network. So we don't have this Docker 0 and Docker proxy, and see how fast it is going. I am showing you this because sometimes it's important, and this is twice as fast, as you can see. It is important to look for those network problems everywhere. See this Lua. So first we have the proxy without Lua. This is this OpenResty, but it doesn't run any Lua code. It just serves the application. And it's going through the Docker proxy, as you can see, because it's not so fast. How fast is it? This is 4,400. Okay, it's this for 4,400, and now Lua. It runs the Lua code that I showed you before. It runs the correlation ID, so every time it calculate the correlation ID, which was just math random from something. We have it here now. How fast was it? 4,400. And here we have 3,500. So obviously we have to pay the price of this Lua, but random is quite heavy actually, and if this would be some just take the file and do something and serve it back, I bet it would be much faster, and still I'd say it's not that bad, but it's for you to judge this. Here are some couple of links. You have for Lua lang, nginx, this is obvious, OpenResty for this nginx module. I don't have a link for Konk in here, but I will update the presentation, so I will put it here. We have this awesome Resty, which is a really nice place with all the Resty libraries and things about the OpenResty environment. And I believe that's it. Do we have any questions?
So thank you for your presentation. It was really informative for us. Maybe it's not a question in a direct sense. I wanted to just share one very nice use case for OpenResty that I'm using on a daily basis. So there's a module for automatic generation of SSL certificates for nginx using
Yes.
OpenResty, so it generates certificates on the fly. So when request comes to HTTPS port, it automatically creates a SSL certificate using Let's Encrypt, and it's great. It really simplifies a lot of things in my case. So that's what
It's
I
really-
wanted to add.
Did you write it yourself, or
No, actually, like it's written. It was written already. What I've done, I've created a Docker container with this module installed and a few, like I simplified to like be able to use it without writing any Lua code. So you just create a normal nginx file, and you just insert one instruction to include a file that I created.
yeah? Is it fast for you?
Yes, it's very fast. Like the
Okay.
certificate is generated like in 15 seconds for the first time, and it has to be done like once per 2 months or so. So
Okay.
it's not an issue.
Okay, it's really good to know. Other use case from the real life I know is that my friend has like couple of thousands of hosts, and he propagate the host matchings on the nginx side through the OpenResty, and he just store it in some, as I showed you, I don't know, Redis or something else, but he just push the changes to his networks, and it's all done through the OpenResty, and no restores are needed. This is nice. So I know the dinner is coming, so if we don't have any questions, then thank you very much. I will be here if you have anything else to ask or something. Just catch me, and thank you very much.
Thank you.